Hey guys, and welcome to another episode of Science Sundays! Right, now that was the coolest intro I've ever done. So, yeah, second episode, last episode went really well, it got a decent amount of views, decent amount of likes, and I'm pretty happy about that. So I'm bringing you another episode. And what you're watching in the background real quick is some of the Last of Us multiplayer. Now you will notice at some points that the gameplays are a bit screwed up, let's just say. It will be like it's fast forwarding. That's not editing, it's just a glitch when I was recording it. For some reason, whenever I record this game, this happens. So, yeah, I mean, it's alright to watch, it's bearable, and it doesn't do it all the time. So, yeah, right, so, Science Sundays. Last episode went pretty well, and if you don't know what it is, it's a series that I'm doing. I haven't even told you who I'm Calvaryn, in case you didn't know, but yeah, so this series is just me talking about random things about science. At the moment I'm sort of focusing on astrophysics because it's my favourite part of science, it's the most interesting to me. I may switch up next episode if I can fit this entire topic into one episode, which I really doubt I will. May do a bit on like evolution, all the crazy things that evolution has like led to. I'm sort of just owning these guys right now. So, see me, I go up to this guy, smash the face in. Oh, I didn't. Well, I'm very disappointed in myself. But, yeah, so what I'm going to be talking about this episode is the Big Bang Theory. And, okay, so I just did an hour of research on this topic, an hour. And I reckon I've got enough information to last me about an hour. I mean, I've got my notes. I can't do it all without notes. I'm not some sort of crazy genius, but I have got a lot of information. So I suppose we'll just get right into this. So Big Bang Theory, as well as being a really, really funny TV show, is one of the theories as to how the universe was created and how it started. Now, even though there's a lot of solid evidence for the Big Bang Theory, you have to call it a theory because, there's other theories as well, and if we just say that, yeah, that's what it is, there is no other way that this could have happened, people are going to get angry, people who believe, who follow the Bible and other stuff, they're going to be like, well, God actually did all this, and I've got nothing against that, I just don't believe it, but, yeah, so that's why we call it a theory. And, so basically, we'll start at the very beginning. Oh, and plus, I don't know if you can hear all this background noise, but it's very hot in England today, and I've got all the windows open, so you may hear seagulls, trains, people, crazy people shouting, cars beeping, stuff like that. But, so yeah, let's go back to the very beginning. So, the Big Bang was said to have happened around 14 billion years ago, and you may know that if we get a telescope and we look further into the universe, we are looking further back in time. And if you haven't heard about this before, you're probably going to be like, what? How the hell does that work? But, think about this, okay? So, say there's a star, okay? And it is 10 million light years away from the Earth. Now, what light years means is how long it takes for light, or how... yeah, for how long it takes the light to get here, so in years. So 10 million light years away means that it takes the light from that star 10 million years to get to Earth. And as you know, the only reason you can see is because light reflects and refracts off of things into your eyes. And then your brain processes it all and stuff. And so yeah, it takes 10 million light years away. So that image that you are seeing is 10 million years in the past. And you're like, that's crazy to think about. So the further you look back, 10 million years back, 20 million years back, if you look at something 40 million light years away, you're looking 40 million years back in the past. And shut up, seagulls. But, so... and when people first hear about the Big Bang, one of the questions they have is, well, where did it happen, If we look in one direction, surely we're looking in the future. If we look in the other direction, surely we're looking in the past. If we're, it can't all be looking in the past. But The weird thing is that the Big Bang happened everywhere. It happened over there, it happened to my right, it happened to my left, it happened downwards, it happened upwards, and that's because the universe expanded from a point. Now, it's hard to think about, and there's a train going past my house. It's really hard to get your head around, but if you can, then you can start to sort of understand other things about it as well. And you may think that that's gives you a bit of a headache, but not really, considering what I'm about to tell you. So, if you think about it, right, the reason why the Big Bang happened everywhere is because the universe was very small at the time. And so, when I say very small, I mean incredibly small, and I will tell you how small it was in a moment. I'm definitely not going to be able to get through all this in one episode. I'm thinking about 5, maybe? But, yeah, so... basically, what... right, let me just think about this a second, what am I trying to say? Right, so another question that people have when they first hear about the Big Bang is, what happened before the Big Bang? What was there before the Big Bang? Well, there was nothing. Okay, and what's crazy is that the laws of physics allow something to be created from nothing. That is allowed to happen. The laws of physics state that something can be created from absolutely nothing. And once you get your head around that, you can actually start to understand how the Big Bang happened and what it was. So, you have to try and imagine that from nothing, just picture black, from nothing we go to a state of almost infinite density, infinite temperature, and infinite violence. And this is all in a single point that happened 13.7 billion years ago, and it is infinitely small. Okay, scientists believe it was around a millionth of a billionth of a centimeter. You can't even imagine that. It's so small. You can't imagine what that is. And to try to help you understand, try to image all the 4 billion galaxies in the universe, okay? Try image like this is hard to image as well. 400 billion galaxies in our universe crushed into a single speck. Okay, that's how infinitely dense, hot, violent, and small this single point was. And the thing is, this single point, it wasn't made of matter, and matter is everything around you. Atoms are made of matter, your legs are made of matter, your hair is made of matter, your chair is made of matter, everything is made of matter. But this wasn't matter, this was just pure energy, which is why it was so violent. And then it exploded, and that's what the Big Bang is, it just exploded. And that meant that all the laws of physics started to form, so they all started to come into place. And the first force that appeared in that moment was gravity. Gravity was essential, and it had to be just right. It had to be just the right strength for the universe to actually form. If there was too little gravity, then nothing would have happened. Everything would have just dispersed. It would have just gone away from each other. None of it would have clumped together to form stars, the Earth, planets, galaxies. Nothing would have happened. And then, but if there was too much gravity, then the opposite would have happened, and everything would have just started forming black holes, because there's just too much gravity, and shut up, Laurie, god damn it, and everything just starts creating black holes. But luckily the Big Bang got it just right, and we have the perfect amount of gravity for things to start forming how they should form. So a fraction of a second after the Big Bang, a shockwave of energy erupted, and it blew the universe in all different directions at an insane speed, so incredibly fast. Astronomers think that in less than a millionth of a millionth of a millionth of a millionth of a second, space expanded by a factor bigger than a million times. And that is crazy. And this is why this is such a hard thing to get your head around, because the numbers are just so hard to work with, because they are so big. And there's a problem with this, though. If this did happen, then this is faster than the speed of light. And everybody knows that this breaks one of the laws of physics. Quote, you cannot go faster. Nothing can... Wait, hold on. Okay, I said that wrong, okay. Quote, nothing can go faster than the speed of light. But, okay. However, prepare yourself for a mind blow. Nothing, speech marks around nothing, can go faster than the speed of light. Nothing being empty space. And that's what was around the universe. The empty space, that's what was expanding, was space. And that can go faster than the speed of light. And it is so hard to understand that, you know, it even gives, like, famous scientists a headache to think about. And, it took less than a millionth of a millionth of a millionth of a millionth of a second for the universe to expand from the size of a golf ball to the size of the Earth. And that, wow, okay, that is crazy. So, everything at this moment in the universe was happening so fast because everything was so close together. It was still extremely dense. And so everything's happening really fast because everything's so tightly packed. And because it happened so fast, scientists had to think of a new unit of time. This is called Planck time. And this is insane. Okay, Planck time, to help you understand Planck time, okay, there are more units of Planck time in 1 single second than all the seconds since the Big Bang. Holy crap. Okay. So, like, now try and think about this. There are more than 31 million seconds in a year, and it has been 14 billion years since the Big Bang. Okay, now times 31,556,926 by 14 million, and what you get is a very big number. Now we don't actually know what that number is because there's no word for it. Well, I don't know that, but I was actually researching this and I got this on something, and that's what it said, which is a bit weird. You get a very big number, but whatever. But that is crazy. That is such a small unit of time that there's more units of Planck time in a second than there has been seconds since the beginning of the universe. And it's just amazing. And if you look at your watches and measure 1 second, you can ask, how many Planck times is that? And that is a billion 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 Planck times. Okay, so very, very small number. Well, a very, very big number, but a very, very small unit. So, in a fraction of a second after the Big Bang, you could fit the universe in your palm, okay? But then a fraction of a second after that, it would have expanded to the size of the Earth. I think I may have got a triple kill there, which is very hard to do in this game, considering there's only 4 people. I don't know if I did, or whether 2 Molotovs were thrown, or what, but I'm going to say it's a triple kill, because I want to. And it expanded to the size of the Earth, so, you know, you wouldn't want to hold it in your hand, because you just get crushed. And as it cools, energy turns into... So as the universe cools down, energy starts to turn into tiny subatomic particles, which is the first kind of matter. And Einstein came up with the equation E equals mc squared. And what that means is energy equals mass times the speed of light squared. So basically what it means is that energy can be turned into matter, and matter can be turned back into energy, like that. And at this point in the universe, there were no atoms. There were no atoms. Everything was just subatomic particles. So they weren't atoms. It was matter, but it wasn't, you know, the elements that we know today. So it made matter, but the universe also made... The universe didn't make it. The Big Bang also made antimatter. And then what followed then was just a massive war, because antimatter and matter collided together, and when they touched, they exploded. And this is because matter had a positive charge. I swear to God, the trains today, there have been so many. So antimatter and matter have opposite charges. Matter has a positive charge, and antimatter has a negative charge. And when they touched, they exploded. So basically it's like a game of Risk. Whichever side had the most soldiers, or the most type of matter, won. And basically we're lucky, because for every 1 billion antimatter, there's 1 billion and 1 matter. And the matter that was left over was enough to create the universe and everything around us today. And I actually might be able to get through this entire thing. To make the entire universe. But there were still no atoms. But as temperatures continued to cool, particles start to bond together, and then they start to make the first elements. They make hydrogen, then they start to make helium, and then lithium. Lithium is an element. I don't know what I was going to say there. But and here's another mind blow. 380,000 years after the Big Bang, the universe started to become transparent, which means see-through. But before then, it was a milky colour. It was like a milky fog. It was sort of like a soup of electrons. There were just electrons everywhere in this sort of soup. And then, as the electrons started to slow down, as temperatures started to cool even more, they started to join with atoms to create the first element. After this, there were clouds of hydrogen and helium that were floating through space. And basically, it would take another 200 million years for these to form into the first stars. And so, as the electrons started to bond with atoms, you know, it started to make all of these different elements, and these elements just floated around space as clouds. And 200 million years later, gravity would cause these to come together and form stars, planets, galaxies, stuff like that. And there we go. Whew. So, yeah, this is coming to an end. I actually managed to get through all this. I thought it was going to take me ages. But I did speak quite quickly. Sorry about the gameplay messing up here, but yeah, so anyway, thanks for watching, guys. I hope you enjoyed it. If you did, leave a like. Comment on what you want me to talk about next time. If you don't, then I'll just talk about something anyway. And I hope you learnt a lot. And please come check out my channel. And I will speak to you guys in the next episode.